Welcome, everybody, to the latest edition of Ask Tom Office Hours for the Oracle Autonomous Health Framework. We have today our guest, Daniel Semler, who's a consulting member of technical staff tasked with working on and developing Memory Guard. A few things for housekeeping purposes before we get going here. First off, this session is being recorded. And as you'll see here with the safe harbor statement, if we happen to discuss something that is future facing or hasn't yet been released, please adhere to the safe harbor statement and its admonishment. Also, I want to say that there will not be any specific SRs handled here on this call. This is not another support channel. This is simply Q&A about the technology and the product and its application. Questions are able to be posted on the chat. Everybody is muted, so you have to actually post your questions on the chat. And we also have questions that can actually be we already have seeded from individuals or are what we consider our own frequently asked questions on the topic. So without further ado, I'd like Daniel to introduce himself before we get started here.
Hi, I'm Daniel Semler. I've been with Oracle in excess of 20 years now. And I've developed a number of features for Oracle database and clustering software. In focus today is the Memory Guard feature of the Clusterware product.
Okay, so with that housekeeping out of the way, first off, do we have any questions from the chat? We've got a few attendees, I see, so if anybody has some initial questions, we can start with those, or I've got some to get started. Please type your questions as we go along this session into chat, and we'll get to them as quickly as possible. But maybe to kick things off here, let's start with a deep question. What is Oracle's goal in developing Memory Guard?
All right. So originally, Memory Guard came out of an understanding of a cause, primary cause of cluster node evictions and or instance evictions, depending on exactly what was the scenario at the time. And it was determined that memory shortage or memory pressure affected scheduling of critical processes, and that in excessive paging or general memory pressure would result in time-critical background processes in the clusterware stack not meeting their scheduling goals, which would then lead to various timeouts that would precipitate a node or an instance eviction. So Memory Guard was developed to try to manage the memory better to relieve those pressures and thereby improve overall uptime of the clusterware software stack.
Well, you seem to have sort of anticipated my next question, is specifically how memory stress actually causes node eviction. You want to expand on that any further?
Just a little. I mean, fundamentally, the problem is that in a virtual memory operating system, memory management is a very high priority task. And when you need to either swap memory out or clean up memory or otherwise make memory available to critical processes or what have you, that will take priority over other things and can cause time-critical processes of another kind to experience greater delay than they would like. And the clusterware stack in particular has node management, node membership tasks that have to be addressed in a timely manner. And so if the cost of freeing up memory, making memory available goes up, then some of these tasks can be impacted in their scheduling. And because of the critical nature of those, we have timeouts in the clusterware stack that we then use to say, look, this node isn't responding adequately. We're going to protect the rest of the cluster by evicting that node, or similar things at the instance level. So, yeah.
Okay. So how does that memory guard actually detect memory stress?
Right. So memory guard has a data feed coming from the cluster health monitor code, the cluster health monitor daemons, which run on every node in the cluster. And we get a feed of data that tells us how much memory is on those nodes, how much of that memory is free, how much of it is in use for such things as operating system caches and so on. And if we feel that that amount of memory is insufficient, we'll consider the node to be under stress.
So what does memory guard do when actually stress is detected? And you can use this diagram sort of to talk about this.
Right. Okay. So we really do two things when we're under stress. We'll detect stress on a node by node basis, and the two things that we do are notify that we've detected stress and try to alleviate that stress by acting on the primary source of it, which will be database workloads. So if you have a look here, we've got the QSM server process, which houses the memory guard feature, the data feed I just mentioned from cluster health monitor there in the upper right, and a connection to the clusterware itself, which we use to take our actions, the two actions that I just mentioned, sending a notification event through the clusterware, or acting on the database workload. The listener's present there because the actions that we take are to prevent new connections to the stressed node, and we do that by shutting down temporarily the database services on that node so that no further work can be added and that existing work can complete and drain off in a graceful manner.
So you mentioned database services. What are these for the members out there that you're referring to?
Sure. I mean, database services have now been around since at least Oracle 8 at the network layer, and they've had a number of features added over the years. But a database service is a network endpoint fundamentally. You come into the database and you specify, I'd like to be in this or that service. The listener knows which databases and which instances are serving up which services. And so the listener in a cluster is responsible for examining the input connect request and saying, okay, which service do you want and which instances can I sort of route you to who provide that service. So it allows for a number of different things like partitioning of work between different applications. You could have a service for accounts receivable, one for human resources management, and so on. It allows for monitoring those applications sort of service by service, so you can see what the arrival rates are, what resource utilization there are, and so on. So, you know, there are a bunch of other features tied to database services, but fundamentally they direct you to a place where you can access the service that you need.
So are there any specific parameters that you need to configure for services when using memory guard, or to make optimum use of memory guard?
I mean, generally, no. I mean, memory guard is fairly graceful in its action. So you don't need to do anything particularly different with the services configuration or parameters. So memory guard itself knows how to interact with a variety of contingencies or situations in respective services. And so generally speaking, you don't have to tell it anything specific.
Mm-hmm.
The one thing I would say is that those services must be services registered with the clusterware, because that's how memory guard will act on them.
So if there's this concept of a default database service that you want to, that's not one you can use in this context?
That's correct. I mean, the database service is not managed by the Oracle clusterware stack. It's up on all instances at all times, and it's generally used for administrative purposes only. It's not intended that it be used for application work, and memory guard itself will not act on it. The expectation being that that particular service is going to have relatively small amounts of work and must be available for administrative operations at all times where, if at all possible.
Okay. Okay. So, by the way, I've noticed new people joining. Please put any questions you might have in the chat and post it to everyone, and we'll get to the questions. You're free to ask any questions as long as they're not a specific SR. So you talked about the fact that services are network endpoints, and that memory guard basically, in a sense, deprives the instance of getting new work on that service to reduce memory stress. Well, what happens if the services are running only on one instance?
Okay, so generally speaking, with services in a cluster, we would normally have them available in some kind of HA operation. If we're already in some configuration where either the service is just running on one node or has already experienced stress on other places, we will generally try and keep the last service member running so that we don't cause an application outage if at all possible. Now, there are two types of services.
So this would be like a singleton service type situation, or?
Right. Well, okay, so singleton and uniform are handled slightly differently because of the expectations on the configurations. But for uniform services, the last man standing, as it were, will be allowed to continue.
Mm-hmm. I see. So speaking of these multi-instance services that you were talking about, if you have a mixture of singleton services, i.e. ones that run only on a particular instance, and services that go across instances, does memory guard actually shut down the multi-instance ones first in trying to reduce the memory stress?
Actually, at this time, memory guard doesn't have any sort of preferential treatment of one service over another particularly. It acts on all the services on a particular node that is subject to stress across all databases, in fact, that are on that node, without any additional heuristics input of any kind. So no, it won't shut down one, singletons versus multi-instance services in, any particular order.
But you had mentioned that it will let the last instance of a service be preserved.
That's true. In the case of a multi-instance service, it will do that. In the case of singleton, the configuration is actually a little different, and those can experience outages of the service. I should probably point out that shutting down the service doesn't terminate existing running work. That work's allowed to run to completion until the session terminates, and then new connections are the ones that will actually see the service being restricted to one or other machines.
I see. Okay, so when we talk about multi-instance databases, we presumably are talking about RAC databases, but I can actually have a single instance database running in a cluster, that is not a RAC database, or even RAC1 node. Does Memory Guard only work with RAC databases, or does it protect nodes that are running single instance databases, assuming clusterware is there?
Yeah, assuming that the single instance databases have actually got their services registered with the clusterware stack, Memory Guard will be aware of them and will be able to act on them. If it's simply a case that you've started up a single instance database, you haven't told the clusterware anything about that database, it will be invisible to Memory Guard. It'll look like just other background work.
Mm-hmm.
Yep.
So in the case where I have RAC and single instance databases on the same node, you're like here, is if clusterware knows about the services hosted by the single instance databases, Memory Guard will work equally with them and the RAC ones. If it doesn't, it'll ignore it. Is that what you're saying?
That's correct, yeah. Yes, that's correct.
I see.
Yep.
Okay. So do I need to do anything to, how do I enable Memory Guard on my cluster?
Okay, so Memory Guard is enabled by default on regular cluster installations after, I want to say 11.203, 11.204. It'll always be present and running. Yep. Okay,
well, if that's the case, can I disable it? So, for example, if I'm doing patching or upgrades, how is Memory Guard handled when my cluster is sort of in turmoil?
Okay, so Memory Guard can be disabled. It's generally not necessary. And the reason is because of particularly things like patching and upgrade. Memory Guard's already aware of what to expect in those periods. And so it should respond in an appropriate manner. So for example, there is some work that goes on in database upgrade, which results in services being shut down. Memory Guard is able to respect that because it knows what's going on. It isn't going to immediately say, oh, okay, I need to start these services. So generally speaking, there should be no need to disable Memory Guard, but in certain cases, it can be disabled if necessary.
Mm-hmm. Okay, so then if that's the case, how do I know that actually Memory Guard is enabled and working on my cluster?
Right, okay, so generally speaking, you'll know that Memory Guard is working. Mostly you shouldn't know. It shouldn't be doing anything if your system is not under stress. If it is under stress and you are experiencing problems with memory, you will notice in the Grid Operations Manager log entries indicating that Memory Guard has detected elevated levels of risk and that it's taking some kind of action. You'll see events being produced, and I believe those can be routed through to Enterprise Manager. And of course, your application may well notice that your services have gone down. So you generally shouldn't notice that it's there. If it starts to take action, it will indicate that it's doing so.
So you'd shown in the diagram and mentioned about the QSM server resource. Mm-hmm. So are you saying that if the QSM server is enabled by servctl, in other words, if it's reported that way, then basically Memory Guard is enabled because that resource is online?
That's true. Yes, that's true. The Memory Guard will be running so long as the QSM server resource is both enabled and started.
Okay. All right. So we have a question in the chat. Linux already has an out-of-memory killer, as do other operating systems, to basically identify memory stress on the nodes. How does Memory Guard work in conjunction with that?
Right, it's a good question. The out-of-memory killers on OSs tend to be unaware of the application-specific nature of particular feature, processes that are running on their machines. Certainly to a greater or lesser degree, but generally they don't know a whole lot about it. Generally speaking, the expectation is that memory guard knows how to act more benignly than an out-of-memory killer will act on Oracle database processes. So an out-of-memory killer might just simply axe an important process, not knowing which to choose and looking merely at memory heuristics. The other expectation is that the memory guard will kick in before the out-of-memory killer. And part of the reason for that being necessary is this lack of understanding of the actual application that's running, i.e. the database. So the expectation is that memory guard will work earlier than the out-of-memory killer and act in a more graceful manner towards the Oracle database.
So instead of letting the session complete its work, the out-of-memory killer could actually kill that shadow process.
It could.
As an example.
Yeah, it could.
Or the instance itself.
Yeah, I mean, these are not unheard of. The other thing is that the out-of-memory killer acts comparatively late. I mean, Linux does try to allow processes to go as long as they possibly can without interference. It's not always the best thing for solving the kind of problem that we're dealing with here. The database can be subject to stress before the out-of-memory killer would really want to act, and so we'll want to act a little earlier.
Right. Okay. So how do I know that actually memory guard has acted and a service was actually shut down by memory guard versus simply the service went offline or etc.?
Right. I mean, I alluded to this earlier, but going over it again, we've got a so-called grid operations manager log in the QoSM server. Yeah, exactly. This kind of thing. It'll say that, okay, I've got a risk level. Risk levels, you'll notice the risk level here is red. We have 3 risk levels: green, which is everything is good; yellow, which indicates we've got some kind of data dropout problem in the feed from the cluster health monitor, and red indicating we've got data and it indicates that you're under memory stress. So you'll see these kinds of things. We'll also send events. And once we have this, you'll see in a second message in the Grid Operations Manager log here saying that a particular server has this risk level and that new connection requests are not being accepted any longer. And this indicates that we've started to shut down or have shut down services on that node. Right.
And so when that stress is relieved, we'll see a sort of a clear message.
Right, exactly. We'll see a clear message, and the memory guard daemon will restart the services that it stopped. At that point, the database application will now be able to use that instance again and carry on with whatever work it needs.
I see. Okay. So when this happens, can I get notifications when memory guard takes the actions, or do I need to always check the logs?
No, cluster events are actually created at the same time as the log entries are made. And they're passed into the clusterware event stack and are visible just like other events in the clusterware event space. So we produce a risk event that indicates what risk level we're seeing, and we produce those on transitions. So when it goes from green to red, and when it goes from red back to green.
And does EM consume these events?
Yeah, those things are available through EM from the version's going to kill me, I'm afraid. I'm not quite sure what version we're seeing.
13.3. It's upcoming version 13.3, I believe.
13.3, right? Okay.
Yeah. And I might also add that TFA can actually index these events as well. Trace file analyzer has the ability to listen for these events.
Okay. Yep. That would be handy.
Because it's recorded in the log. Yeah.
Mm-hmm.
Okay. So does, we've been talking about sort of the database tier. Does the application tier need any specific configuration to be, quote, memory guard aware? Or does it need to understand that it can lose connectivity to an instance?
Strictly speaking, no. The connection pools in the mid-tier are going to see only that the service is shut down, and they'll see that like a regular HA event. And when they do that, the pools will do whatever reconfiguration operations they normally undertake. So, for example, they'll close down connections to that instance, potentially idle connections. Checked out connections will still continue to be in use until they're checked back into the pool. And then when the pool's asked for more connections, they'll simply request them from the listener, and the listener will route them to nodes that don't include the one that the service has just been shut down on. So the mid-tier really doesn't need to know more than it already does. It just looks like, the service is no longer offered on a particular node.
So what I'm hearing you say is, as long as the mid-tier pools are not configured to a specific instance, they're able to get connections from the listener based upon, whichever instance is available. There should be no transparent. It should be transparent.
Yeah, I mean, you make a good point. If the mid-tier connection pools are not configured to use services, there will be problems. If they're configured to connect directly to a particular node, that's not going to be good. Generally speaking, if they're configured to use in the way we recommend, which is to say to use services for the application, then no, they'll be fine.
I see. Oh, okay. So we have connection robust features such as application continuity. Do we recommend using application continuity in conjunction with memory guard to make it more reliable, or is it necessary?
That's really a choice for the application and DBAs and the application management people. There's no need for AC with memory guard, and there's no real sort of downside to having them both in place. If you want application continuity for the failure features that it provides coverage for, fantastic, just enable it. The reason I say that is this: memory guard does not terminate active connections. What it does is it shuts down services so that new connections cannot be created. Application continuity, by contrast, works for failure cases where an actually running connection gets terminated for some reason, and you need to work out whether you need to replay or recover in some way. Memory guard just doesn't provoke that kind of failure. So
I see. Okay.
The two essentially work together.
Yeah, we have another question from the chat.
Sure.
And asking, what if the FreeMem metrics keeps on decreasing, but from a database standpoint, it's confirmed that the processes consuming memory are not Oracle processes? Say somebody started a big backup job or a FTP job. What action would memory guard take there, given that start-stop services will effectively not help,
right,
or that it's not Oracle processes eating up memory here?
Right. I mean, that's a really good question, and it currently constitutes a weakness in memory guard, or a lack of feature. If the primary consumer of memory on the box is not an Oracle application as described, an FTP process and so on, there's nothing memory guard can do that's helpful there. And if, for example, we do turn off services because of this memory stress, in certain sense, you're not going to you may prevent an eviction, and if the FTP process doesn't continue to suck up memory or manages to complete and so on, that may help. But fundamentally, memory guard will not see or act on those things. It'll look like another memory consumer.
However, however, I do think there's an advantage here in the sense that by causing new connections to go to different nodes, even if I end up losing that node because of memory stress, eventually because of CRS, my workload will have largely migrated to other nodes.
It is true that there is that advantage. We cannot terminate the FTP process, as an example, because we have the same problem the OS memory killer has. We don't really know what it is. Mm-hmm. We don't have a good knob to control it with. But you are right. We could, in theory, lifeboat our own application workload by shutting it down here and getting it out of the way, and that it will do. So we can't, to answer the question, we cannot act on the FTP process, but we may be able to sort of protect the workload a little bit. You may still lose the node, but as you point out, much of the workload will hopefully have already migrated.
Right. So, I mean, it is an availability solution, even in that particular case.
It is. It is. I mean, the application will generally be migrated away from the stress, but people shouldn't look to this as a general OOM substitute.
Sure.
Right.
Sure. Okay. So you mentioned that about singletons. When it stops a singleton service or a service that is running only on a particular instance, since I am in a cluster environment, will the service be started on another instance automatically for me as a result of that stop?
Not currently. The singleton service support that we have will stop the service and restart it, but we won't actually migrate a service from one node to another under memory guard control. Now, of course, the user's free to move that service as they wish, but memory guard won't do that currently on its own.
So it's not CRS does not see the memory guard action as an HA event for that service.
That's correct. It sees it more as a planned stop.
A planned stop. Okay, so that's why it doesn't choose to migrate it then.
Right.
Okay, so we have a availability feature called Global Data Services that we introduced in 12. How does memory guard stopping of services interact with GDS?
Okay, so the Global Data Services will essentially federate services across multiple databases in distributed network domains. So what will happen is it'll look like the service is either serving fewer instances in a particular domain because one node has shut down the service that's part of the global data service. And so that may make their routing algorithm choose different places to route to and so on. But generally speaking, it's essentially benign. You have less capacity at this site temporarily for new connections. Other than that, there's no real impact. The work that's going on the services will continue until it completes, and then it'll log off, just the same as we'd been discussing about regular single site 3-tier apps and so on.
I see. So Oracle has another availability technology, Active Data Guard, which interacts with services. So how does Active Data Guard and Memory Guard behave together?
Okay, so there's actually an important feature of Active Data Guard here, which Memory Guard is specifically taking, that recognizes specifically if this feature is present. Services in a data guard environment can be set up to have a role. So they will be either standby or primary role, and likewise the database instances will have a standby or primary role. And the thinking behind these things is that the services can start only in the site which has the same role as that defined for the service. So you don't end up with your standby services running on your primary database, nor vice versa. Now, Memory Guard, when it interacts with services in this kind of environment, makes sure that it doesn't violate those conditions. So it'll respect the database and service role mappings that have been configured by the user.
Mm-hmm. I see. So it plays rather nicely then.
Yes, it does. Yep.
So you talked about getting data from CHM and being hosted in the QoSM server process. So what is the overhead of Memory Guard in a cluster? Is it on every node? Is it? I mean, what?
Well, portions of it.
Yeah,
I mean, portions of it, I suppose, are on every node. In that, Cluster Health Monitor is collecting this metric data on every node. Now, Cluster Health Monitor was collecting this metric data before Memory Guard came along. So in that sense, that background collection cost was always present, and it's known to be extremely slight. The metrics that we collect are really quite small in number. It's the actual current maximum amount of memory on the box, the free memory, and the memory allocated to such things as the buffer pools and Unix buffer cache and so on. So there's not a lot of load in the collection side. The Memory Guard feature itself runs sucking on that data from all nodes. It runs in a single place, in a single daemon, and that's the QoSM server. And again, simple collection and assessing of the memory continues on a periodic basis, and is generally extremely low cost. Again, we're just pulling in these data feeds from nodes, comparing the risk levels with the thresholds that we have, and making, then so long as nothing's being done, then that's the end of the work for that cycle. So the overhead, generally speaking, is extremely slight. The place where people may notice some spikes in CPU usage in the Memory Guard process in the QoSM server is when it actually then has to act. So if you've got memory stress, then you'll see a little bit more work being done for shutting down of the services or restarting them. But again, very, very slight.
Mm-hmm. Okay. So you mentioned about Cluster Health Monitor, giving the data to the QoSM server. Now, Cluster Health Monitor depends upon the management repository to archive its data. Is that the source of the data, and therefore will Memory Guard be disabled if the management repository is not there, or does Memory Guard still work if you're not using the management repository?
Right. Okay. So the Memory Guard feature does not acquire the data via the management database. It gets it directly from the logger on the Cluster Health Monitor. So it's IPC messaging. So no, if the management database is down, if the management database is not configured, Memory Guard doesn't mind. It'll carry on.
Okay. So we have another question from the chat. So this individual is trying to understand if such cases like RDS memory consumption would come under Memory Guard's purview, or if this will be considered as just another non-Oracle OS process.
Yeah, the latter. I mean, we don't do anything specific with RDS memory at this time. So no, that'll look like just background memory load. Now, generally speaking, it'll lower the free memory. And so again, it's something to do with, is the box configured adequately to handle all the memory demands? And so memory guard will look at that and go, okay, well, we've got a reduced free memory, and so long as the workload all fits still, that's not a big deal. But we don't do anything specific with that yet.
So it basically will still cause memory guard to redirect work to other nodes if it puts that node under stress as a result of its consumption.
Granted, yes, it will. Yes, it would.
Okay, and so
it's very like the FTP mentioned earlier. Yeah.
Right. Exactly. Okay. All right. Since it's enabled by default, do I need any special license to make use of memory guard?
You do not. I mean, memory guard's a feature of the clusterware. So if you're running the clusterware and all those licenses are fine, you're good to go. There is no separate licensing of memory guard.
So it's just a built-in feature of the clusterware, basically.
Absolutely. Yeah, that's exactly right.
Yeah. Okay. All right. So can I customize any settings with regards to memory guard? Since it's enabled by default, I'm obviously not turning it on, but are there any user customizations that, such as memory threshold, that I can have access to?
These things are customizable to a certain extent. But they're done through Java properties. So it's not exactly a nice sweet interface, but nonetheless it is customizable where necessary. Generally, we've tried to pick sort of the best kind of default that we can. So hopefully customization is a rare thing. But the things that you can customize are the basic threshold that we offer, that we work with, which by default is about 512 meg of free memory. And what we consider to be free of the caches and the buffer pools memory on the OS. So we'll get a metric saying that a whole bunch of this cache memory is in use in the page cache and the pools. And for the most part, that memory can be relatively cheaply reclaimed. And so we generally consider it all free. However, that's not always true. Some of that memory can be dirty. If a substantial proportion of it is dirty, reusing it is expensive. If that's common on certain configurations, then the amount of that memory that we consider to be free can be tweaked through a configuration parameter.
Okay. All right. Okay. So you mentioned about, obviously, if I'm shutting down work between nodes and having sort of connections opened up on other nodes, can memory guard's actions result in sort of a cascade failure similar to what an HA event could do? Because obviously an instance is failing over in an HA event, and there's a risk there of cascade failure. Does memory guard have that same risk, or does it have mitigating code that would prevent that?
Yeah, it was worth, I guess, talking briefly about the distinction between those two kinds of events. In an HA event, particularly in something that loses as much as an entire instance, a lot of work is in an in-doubt state and must be recovered. So at failure, another instance must actually go off and do recovery. In addition,
like
you have
DRM.
I'm sorry?
Like DRM.
Right, well,
Dynamic
DRM,
remastering.
Dynamic remastering, though, I'm not sure a relative cost. The main thing is the transactions have to be recovered, which means you're going to go through the redo logs and apply those things, which are inherently a little more expensive in in the cost. The other thing is that you're going to lose all the connections on that node immediately. So they're all going to have to find a new home immediately. So what you get is a combination of instance recovery being required and some kind of logon storm or a substantial number of logons that have to be sort of made and completed in a comparatively short time. Memory guard actions don't induce that kind of failure mode. What they do is they simply stop the services on that node, so new connections can't be made to it. All the existing work will run to completion. So in that sense, first off, you don't have any instance recovery required. So long as we act quickly enough and that's adequate for the memory trajectory and the usage of the memory, what'll happen is all the work will complete. Now, the work won't all complete simultaneously. It'll complete in a staggered fashion, and then sessions will log off and new sessions will be created. So in general, memory guard's impact on the system should be much more graceful, and you'll have less recovery, in fact, hopefully none, to do, and you'll have a much more staggered sort of failover behavior, and in fact it'll look more like disconnect and reconnect, and it'll occur over a longer period of time than normally occurs for an HA event. So the impact overall should be much better.
So the likelihood of this type of failure is dramatically smaller than waiting for the node to just overload and evict.
Absolutely, yes, it is. I mean, one of the big problems with an HA outage precipitated by a memory problem on one particular node is the fact that the actual failure and then subsequent recovery are both very disruptive actions. Yep.
Okay. So we have another question here. Apparently we have machine learning models being applied for components like Cluster Health Advisor, Hang Manager, etc. Do we have any machine learning models being applied for Memory Guard as well?
At this time, that's not happening, but it's an area of investigation that we can look into for Memory Guard's own algorithms, in particular things plotting, memory, what constitutes normal memory behavior and so on. Yeah. So there are interesting things to be done there.
Yeah, I will add that already CHA does have a memory monitoring and predictive component to it, and that we are actively investigating connecting up as a data point for Memory Guard what Cluster Health Advisor believes the memory issue is, and basically could use that as an additional data source, such as we use with Cluster Health Monitor, to indicate that we might be wanting to pull the plug a bit earlier than we would otherwise do so with simply getting static OS data.
Yeah, granted. Yeah, definitely and there's definitely opportunity to link these two together and provide that kind of support into Memory Guard.
Right. Okay. So that's my canned questions, but do we have any other questions from the audience with regards to Memory Guard? Okay, so another one is, would Memory Guard provide any notifications for autonomous databases?
Nothing specific beyond what we've already got. I mean, as we've described before, we've got notifications of the database that can be picked up in EM, and
yeah, I can actually answer that for this. As was mentioned, we have trace file analyzer support for these notifications, And when we're talking about the autonomous database, I'm assuming we're talking about such as ATP, and that the actual data, the events that actually are collected by TFA, memory guard events will be part of that payload.
Right.
So in fact, but remember though, as an autonomous database, the audience is really the back-end operations people versus the customer. So right. In other words, the whole point of the autonomous database is the DBA doesn't have to monitor availability and doesn't have to deal with these things. So that basically is data and events that are going to the cloud admin with regards to managing the availability of the nodes. Another question. So the question was, so the customer can be notified accordingly so that he can scale up his resources. Well, that obviously is a sort of a different matter. We would hope that the scale up based upon memory requirements is actually triggered far earlier than memory guard would need to be triggered, right?
Yeah, I mean, it's kind of an operations question and customer, provisioning question. But yeah, I agree. It would be better that memory guard not be used to trigger that kind of thing at this point. You
right.
Do that off something more monitoring, trended usage and so on. Right.
Okay, so any other questions? We're getting up to the top of the hour here. It looks like we've gotten everybody's questions out of the way. So I want to just mention that we will be having an actual session next month on the 26th. And coincidentally, or by plan, it is going to be talking about Cluster Health Monitor, which was the back end of memory guard and is the back end of many components that are part of the autonomous health framework. So I welcome everybody to submit questions and join us at the same time on the 26th for that session. And we'll be having another developer join us. And finally, we do post all of these recordings, all indexed up on the Ask Tom Office Hours YouTube channel. And so you can look for a replay of this in the next few days after it gets edited and uploaded, etc. And you can subscribe to that channel with your favorite subscription application or from YouTube itself. So this gives you an ongoing resource for this information. So I want to thank Daniel for your insights and everybody for joining us this week. And until next month, we're signing off here.